Okay, so for those of you who are new, right, we actually do these meetups quite regularly. We usually rotate between OpenShift meetups and Ansible meetups. So this is the QR code if you want to join the group on meetup.com. This is where we post our events, any agenda, synopsis, all will be there as well. So let me just leave that for a few seconds if you want to scan.
Is this the same code you gave us for access?
Oh, no. This QR code will lead you to meetup.com, and then we have our own group over there. Okay, so today's agenda will be pretty focused, right? So firstly, I'll be introducing Skupper, and then I'll be talking about how we implement Skupper in 4 easy steps. So I've broken down the implementation into 4 steps for Skupper, and then I'll move on to the benefits of Skupper, right? So how is Skupper actually benefiting in today's real world use cases? Right? And also have some use cases at the end of the session. And if you have any question and answers, maybe you can leave it to the end of the session, and then we will try our best to answer your questions, right? Okay, so let me start off by talking about this single cluster architecture, right? So let's say I have an application, right? It needs to use an API service, for example, and then we also have a third component that is database. So in this single cluster, when we talk about networking or communication between the 3 components, right, it's going to be very simple. We don't have to worry about adding a new configuration for networking or to actually enable the communication between the 3 components, right? We don't have to worry about much for the networking part. But this is a very paradise kind of architecture, which we don't normally see in real world scenarios, right? Because we have a lot of brownfield applications. What do I mean by that? So applications can run on a diverse mix of environments, right? So firstly, if, for example, you have applications that are running on Red Hat OpenShift, it could be running on different versions on OpenShift, right? So that's again, different environments. You could have applications running on other Kubernetes offerings like EKS, AKS, or GKE, or even vanilla Kubernetes. Right? Again, you can have some applications running on bare metal and VMs. And then you can have some applications that are still running on legacy system, right? You might have some reason that you can't modernize these applications. So you have a diverse mix of environments. Your applications are running on all sorts of environments. And this is when the networking and communication becomes scary and complex, right? Some of the common challenges that we have is how do we enable the connectivity between, maybe let's say your applications are running on public cloud, some are running on private cloud. How do you enable that communication? Another common case that we have is you have your edge applications. You have your edge applications, we want to try and use public cloud to actually enable the communication between your applications. So these are 2 common challenges that we face. Today, there are some solutions for those, right? So most commonly, we have the VPN implementation or even VPC. So that's one way of, solving the challenge that we saw earlier. The other way is, implementing a gateway that will actually manage the communication between all the different components. So this is how, some of the solutions are out there today. But more interesting and a much more simpler way is Skupper, right? So what exactly is Skupper? Skupper is actually a layer 7 service, and then it actually enables the secure communication across your application on different Kubernetes platforms, right? You don't have to have any additional VPN or firewall rules, but at the same time, the security is upheld, right? So the keyword here is layer 7 service, which I'll explain in the next few slides. But to understand the value of Skupper, right, I think it's very helpful that we understand what a virtual application network is first, because Skupper is actually based on this very architecture. Right, so firstly, virtual application network, how does it work? What does it do, right? So when connects the applications and services that are actually deployed on different environments. So you can see in the diagram here, we have 3 different sites, and you have services across these different sites. What a WAN does is actually enables the communication between these 3 different services as if it was all in one single site. Right, so how does it do this? The backbone for virtual application network would be the layer 7 router. So a layer 7 router works exactly the same way as your traditional router. The difference would be that layer 7 router would use application endpoints, whereas your traditional routers use network endpoints to communicate across each other. So that's the difference here, and that's the key over here in a virtual application network. So for example, if my service B wants to send a message, service B sends a message, the local router on site 2 would actually receive this message. And because my service A and service C are both subscribed to the same address, they would actually be able to receive this message that service B was sending from a different environment. So that's how virtual application networks work and how Skupper actually is based on. And where do we come in, right? So where does Red Hat come into the picture and how do we associate with Skupper? We have our product called Service Interconnect, which is based on the 2 open source projects. So firstly, it uses Skupper as the open source project, and it also uses Cupid as the other open source project. So these are 2 very well-established projects, has been here for a few years already. So as you can see, the numbers speak for itself, right? Cupid has been here since 2014, and Skupper has been here for over 3 years as well. And you can see the buzz and interest about these projects. When I initialize Skupper later in the demo, you'll be seeing, right? When I initialize Skupper, you'll be able to see 2 components that gets deployed. First one would be my service controller, which is based on Skupper. And then I'll have another component called the router, which is based on Cupid project. So those are the 2 components, and these are 2 open source projects that Service Interconnect is using. And so generally how our products get deployed, right? We always go by this policy called Upstream First, right? We are always giving back to the community, contributing to the community first. So in this case, we actually actively contribute to these Cupid and Skupper projects. And then downstream, we have our own enterprise-ready product, which is called Service Interconnect. Okay, so the main aim and mission of Service Interconnect and Skupper is to simplify the connectivity across your different platforms, clusters, and clouds, but at the same time, maintaining that security amongst these connections. So how do we do that? Firstly, we are in Skupper is application focused, right? So it's all you have your individual apps running virtually on any platform, and you can make these TCP calls to other apps which are running on other platforms. So the key here is that the applications are talking to each other rather than traditionally you have your network endpoints talking to each other. Right? The security comes in because we implement using the MTLS encryption. So a mutual TLS works exactly the same way as your TLS works, just that this is more advanced because it is two-way handshake. So that's what I mean by mutual TLS. And then application layer abstraction. So it is very agnostic of the IP versions and the environment of where your applications are. Right. And lastly, it is layer 7 addressing. So like I mentioned, it actually uses the application endpoints instead of network endpoints. So this is how we actually get to the conclusion of that Skupper can actually simplify your connectivity between your applications. Okay, so moving on to the demo. I'll just run through the steps first, and then I'll show the demo. But essentially, I've broken down this implementation of Skupper in 4 simple steps. Right, the main aim of the demo and Skupper is to be able to connect your services spread across different environments. So the goal is very simple. We want to be able to let service A talk to service B, even though they are on different environments. So for example, if I have my front end on my public cluster and my back end on private cluster, how do we enable this communication? Right, so the first step would be to initialize Skupper. So just give me a minute. Let me just set up my demo. Okay, let me run through the 4 steps first, then I'll shift the screen. Right, then after initializing, so when I initialize the Skupper, right, like I mentioned, there'll be 2 components deployed first. One will be my router, one will be my service controller. So these 2 components will get deployed. After I do that, I'll have to create a secure token on one of the environments, and that has to be the public environment. So if I create my token on public cluster, where my service A is running, I would then link the token into my other cluster. So this is the key here, right? Once I link those 2 tokens, this is when the link comes up, the connection comes up. And after this, my service, if I do expose my service A, service B would actually be able to receive the messages from service A. right? So that's the main aim of the token creating part. Like I said, right, you have to expose the deployment or service explicitly. So this is obviously to reduce security risk or any sort of risk. Developers have to actually explicitly expose the deployment. So whichever services they want to expose, they will have to explicitly mention which service they want to expose. Okay, so let me just set up the demo and then I can show you live how we do this. All right, just give me a moment. Okay, so here what you can see, right? So I've actually have 3 different environments. So my first environment is an OpenShift cluster running on AWS in my US region. So that's my first environment. My middle environment over here is another OpenShift cluster running on AWS as well, but this time it is on Asia Pacific region. So those are 2 environments. And lastly, I have my local Kubernetes cluster running locally. So 3 different environments, right? And what I've done already is I've actually deployed a simple Hello World application. So over here, I have my backend application. Over here, I have my front end, which I'll show you again. But this is where my backend is. This is where my front end is. And I've actually deployed another backend here for high availability. So I want to showcase high availability part and what Skupper can do in that part. But essentially, high level, this is what the environments are. So again, backend, front end, backend. Okay, so following the steps earlier, right? My first step was to initialize Skupper. So let me just do that for all 3 environments. And then I'm going to call this maybe, let's say, AWS US, because it's my US region. And then same thing I'm going to do here, right? So in this case, I'm going to enable my Skupper console in this environment. So I'm going to do an additional thing here. So I'm going to Skupper init as well. And then here, I'm going to enable my console. And I'm going to call this, let's say I'm going to call this AWS Asia Pacific. Okay, so when I get OC get ports, right, you can see that I have my 2 components for Skupper. One is my router and one is my service controller. And of course, like I mentioned, I have my backend port as well. So that's for my first environment. Over here also, I would be able to see the 2 components, so 3 components for Skupper in this case, because I have my console deployed here. So you can see my router and service controller here as well. And here I have my front end application. And then previously I had my backend. So let me just do it for my local cluster as well, the same thing, Skupper. And I'm going to call this local, right? Okay, and what I can do is actually I can do a Skupper status to see the web console of Skupper here. So you can see that I'm able to see the endpoint of the Skupper console and my credentials where it's stored as well. So let me just retrieve the credentials first. Okay, so this is how a Skupper console looks like. And for now, I only have one component because this was where I actually enabled my Skupper console, which is the Asia Pacific. So I'll put it side by side so it's easier to understand. Right, and the main, at the end of the demo, I want to show that I'm actually able to establish my connection between this environment to my other two environments. Right, so for ease of understanding, I put my Asia Pacific symbol beside the actual environment. And then I want to be able to create that connection between the other two environments as well. Right, so if I go back to my steps, the second step would actually be token create. And where am I going to do this is I'm going to, for this demo purpose, I'm going to create the token in my middle environment, which is over here, Asia Pacific region. Okay, so let me go and do that. So Skupper. And I'm just going to call this simply, let's say, secret. Or let me just call it AWS AP secret. Okay, I'm going to create the token on this environment, and you can see it's actually written into the YAML file. So if I'm going to view that YAML file, this is how my secret looks like. Okay, so it's in a YAML format. And then what I'm going to do now is actually I'm going to copy all this content because I want to link this token onto my other environment. So what I'm going to do is I'm going to link the token onto my top environment, which is running on US region. So I'm going to create the file first. I'm going to call it the same thing, AWS AP secret.yaml. And I'm going to paste the content that I just copied. And once I do that, I can now do this step. So the step after this. So I'm going to link the tokens now. Okay, so I'm going to Skupper create using the same file name. Okay. So wherever I've stored the password. So I stored it in AWS AP secret.yaml. I'm going to use back that same name. Okay. And I can give it any name, right? So let's say I call this AWS US to AWS AP. That's the link name.
You want me to join the call on that, right?
So you can see that the site has been configured to the link. So in a few seconds, right, I should be able to see my US region pop up over here. Or another way I can do that is I can do a Skupper link status as well. So you can see it's connected here. So if I just, so if I refresh and in a few seconds, I should also be able to see the link between these two created. Okay, so you can see that the link was created now. So in a way, if I were to actually expose any deployment on my top environment, this environment would actually be able to retrieve the messages or make TCP calls the environment on top. So if the front end is here, back end is there, I'll still be able to do that communication because I've created that link. Right, so that's one environment connected already. Let me connect the third one. So the same thing I'm going to do, I'm going to create another token here. Same thing, I'm just going to copy the content. And I'm going to create the link over here. So first thing, I would actually create the file first. Okay, and I'm going to paste the content. And I'm now going to link it. So Skupper link create using the same file. And I'm going to call this, let's say, local to AWS AP. So that's any name that you can give, but for ease of understanding, that's the name I've given. All right, so you can see that the site is also now configured. So in a few seconds, the same thing, you'll be able to see a third component here. Or I can do a Skupper link status to see if it's actually connected or not. So you see it's connected, and then let the link get up there. Okay, so now there is a link created between all three environments, right? So I have my Asia Pacific cluster, OpenShift cluster running on Asia Pacific, being able to retrieve, messages or be able to make calls into my AWS US region and even my local environment. So you can see the link is created, but to test it out, so let me try and test it out to see if it actually works, right? To be able to show that my middle environment, which is my front end, is actually able to retrieve messages from my other two backends. So what I'm going to do here is I'm going to curl in my front end application. And before that, there is one last step. So we have to expose the service first. Remember that by default, this won't be exposed. The services are not exposed to each other. Even though the link is created, the services are not actually exposed. This is, of course, to reduce any security risk or anything or less privilege. So what the developers will have to do is actually expose only the services that they require to be able to communicate with each other. So I'm going to do that. So I'm going to Skupper expose my backend deployment here. And the same thing I'm going to do here as well. So if I do a Skupper service status here. Okay, so what happened here, right? When I did a Skupper service status in my front end environment, which didn't have any backend deployment, I'm still able to see that service through Skupper. So this service was actually because I exposed my services from the top or bottom. Now it means that my front end is actually able to communicate to this backend service. Right, so to test it out, right, what I'm going to do is actually, let me curl into this environment first, and let's see what message I get from this backend environment. Okay, so I'm going to curl. And then this is my namespace. And then this is the route I should follow. Sorry. Okay, so in this environment, I can see that my message is, hello, stranger, I'm a Primo program. Right? Don't ask me why the message is there, but this is the message I get in the first environment. And then you can also see that this is the port number I get. So this means that it's using the port from this environment, which will be useful later when I show. But this is the message specific to this environment. Now, if I do that over here, I should get a different message. So if I go into the port, right? So if I go into this backend port and do the same thing that I did earlier, which is the curl statement, I'm going to do a port, and I'm going to call my localhost. Okay, so here, what do I get? I get, hello, stranger, I'm a BT widget. So you can see these are two different messages that I get because these are two different backend environments. But my aim of this demo is to be able to show that my front end is actually able to receive these messages, right? Either one, of course. What I'm going to do now is also do the same thing that I did here, but in this environment now. So I'm going to do a curl and then my namespace. Okay, so what happened is that my front end was actually able to retrieve the message. So in this case, it is actually using the environment on top. But the interesting thing about Skupper is that you can actually define which, for in this case, because we have two backends, right, for high availability, we can actually define a more efficient way of retrieving the message. In the case where there's so many backends, how does Skupper decide which backend to choose? And that's the interesting thing about Skupper. You can actually define the most efficient way by doing like initializing an integer, for example. If, for example, later I have in the slide, but essentially, Skupper will be smart enough to choose the most efficient way. And another thing that I want to show is that, let's say my deployment on this environment actually gets scaled to 0 for some instance, right? It goes down. So what I'm going to do is, let's say I'm just going to OC scale to 0 first. Okay, so I don't have my backend running on my US region. Now, how is Skupper going to resolve that? So if I do the same thing over here, if I do a curl, yeah, so what happened was, even though the port on top was actually scaled to 0, Skupper was actually smart enough to find the alternate route. And the alternate route in this case was to actually retrieve it from my other backend deployment. Right, so that's the beauty of Skupper. So even though there is a port goes down in my first environment, Skupper would actually find that alternate route and retrieve that message as if that nothing happened. Right, so that's fallback scenario kind of use case that Skupper can do. You can also actually, on the console, there's quite a few interesting things, right? You can actually see visually how the connections are going. So because I've actually scaled the deployment to 0 on my US region, there is no more link between the two components. Now, the middle component, which is Asia Pacific, is actually retrieving its message from local deployment, local backend deployment. Right, so that's how Skupper essentially can work smartly. There's a few other components that is quite interesting on the Skupper console. You can actually see metrics. I think I've put a screenshot. So yeah, so just now what we saw was a service interruption use case, right? So firstly, we had both the backend pods running, but when I did a scale to 0 scenario, Skupper was actually smart enough to find that alternate route, even though there is no more link between my US to AP. That was the service fallback use case. Another interesting thing was you can actually see this component view. You can actually see the transmission between the different components and processes. This is actually quite useful because whenever there's a port goes down, right, you can actually see where the transmission of data is actually coming from. Right, so this is quite interesting as well. Yeah, so the main aim of the demo was actually to have that secure connectivity established. In my demo, there were 3 environments, but in this picture, 2 environments. What the idea is that you have a service A on one environment, you have service B on another environment. How do we establish that connection between those 2 services securely, right? Even though the components are all on different environments. And that is what Skupper or Red Hat Service Interconnect can do. Right, so the benefits of Skupper or Service Interconnect, it is very simple, right? In the demo, you could see how simple it was. Firstly, there was no code changes involved in this. No network changes, right? Traditionally, you would use your VPN or VPC. You would need to configure a lot of different network changes because you have a different environment. And the last point was that there is not much privilege required for this, right? No additional admin privilege required. When it comes to VPN, you would actually involve your infra team, for example, or you need cluster privileges to actually establish that VPN connection, right? So that's one benefit of Skupper. You also have quite a few different commands here, so you can see the available commands. It gives you that service management, so it gives you that visibility of the individual services in the network. It also creates the tokens securely establishing using the mutual TLS connection. You can manage the lifecycle of Skupper and also manage the links that you actually create. So this is how Skupper Interconnect console looks like. So it's similar to, Service Interconnect console looks like. So it's similar to Skupper, right? You have different menus, like for example, topology, component side, and this, what we saw in the picture earlier, providing the traffic related information as well. Right, so another interesting thing for OpenShift, we actually have a service interconnect operator. So this actually simplifies the installation of Skupper, right? So it's easy to install for the whole cluster. It is also for configuration tuning on day 2 requirements, right? It also becomes a lot simpler because you have this available to you as an operator. Right, another key benefit of service interconnect. So when we talk about what was the reason applications were made portable, that's when containers comes in, right? Containers were the reason you can now move applications from one place to another effortlessly. When we talk about data, right? Object storage data was the reason why you can now move data stored from one location to another in a very simple way, right? But when you talk about networking, right? There are still a lot of cases today where, for example, you need to configure VPN or VPC, right? It becomes very troublesome because you have to create that additional configuration. So this is something that is still not exactly portable, but this is where Service Interconnect comes into the picture. Right, it makes it very simple because it operates on layer 7. So we're all familiar with the OSI model. Service Interconnect or Skupper is based on layer 7, which means that we actually communicate via the application endpoints. So this is why it becomes a lot more simpler. But at the same time, even though it's simple, right, it does have that protection required. So it implements using the MTLS encryption, so mutual TLS encryption. What it does is it only exposes the specific application components that you specify. Right, it doesn't go and expose the whole subnet. And a lot of times when we have, firewall configurations, so if we do need to open firewall, for example, a lot of times there are times that, we forget to close it back, and that arises to security pitfalls. So because Skupper uses the MTLS encryption, those pitfalls are actually avoided. And also it has that network isolation. So like I mentioned, right, none of the services are actually exposed by default. But the main reason is you want that network isolation, and you only expose what services are required. Right, and of course, you can have these applications on a hybrid environment, right? You can have it on a virtual machine, you can have it on OpenShift cluster, you can have it on Kubernetes cluster, or you could have it even on a bare metal host. Right, just now we saw one of my environments was local, and then the other two were OpenShift clusters running on AWS in different regions. So you can also have that indirect connections among the services. So it doesn't have to follow like a certain or definite path. You can have indirect connections between the different services and components. And another thing that I was showcasing in the demo, high availability. So in the case where in demo, when I deployed or when I scaled down the deployment to 0, there was no more connection, but Skupper was actually smart enough to find that alternate route to get the information required. Right, so this was the other interesting thing that I was mentioning. So how do you tell Skupper what is the best way or best route to follow? You can actually define this in terms of integer values, for example, in simple integer value for example, you have your communication from your virtual machine to my OpenShift cluster, let's say it costs $5 versus my communication that from my virtual machine to a Kubernetes cluster on public cloud that costs $200. You can define all of this to Skupper and then tell Skupper to use maybe the most cost-efficient way. So that's something very smart that Skupper can actually do for you. All right, so let me just go through some of the use cases in today's world. So if you have some traditional applications running on a virtual machine, how do you actually manage this migration of applications into an OpenShift cluster? And that is how, so Skupper can actually help this way because let's say you have a few microservices or few services that is still running on virtual machine. You want to move them out to your new OpenShift cluster one by one. And because that connection is there between the two environments, your application will be still running the same way as it was. So if I can just draw on the whiteboard quickly, right? So you have your VM over here. And let's say you have a simple customer-based application. So you have your customer, this is one service, and then you have another maybe inventory service. And then maybe let's say you have a price service. And then you want to move it to an OpenShift cluster. Right, so after you initialize Skupper on the two environments, let's say this is my Skupper component. The link is now created. But how do you want to migrate? What's the best way to migrate from all these applications to my OpenShift cluster? You can actually do that one by one, right? So let's say I move my customer service first. So this goes into my OpenShift cluster. But in this time frame, right? If I still want my application to have no downtime, because of Skupper, this service is actually able to talk to my inventory service or even talk to my price service, right? Because of Skupper. So this is how, even though you don't want downtime, you want to migrate, this is one use case that Skupper can actually be very helpful. And the key thing is that you don't want to actually risk, moving all of this one by one, because if there is downtime, you're going to lose cost, right? So smaller units of migration always helps you to reduce that risk and the need of massive funding for migrating. Right, so progressively moving out your services and using Skupper to actually establish that connection between the two environments will actually save you a lot of risk and funding as well.
So you mentioned about moving what traditional application that runs on what kind of environment? Virtual machines.
Yes. So in this use case, my traditional applications are running on a VM. I want to move it to a Kubernetes cluster, which could be OpenShift. Right? How do we move these separate services or components one by one to my OpenShift? So the thing about Skupper is that actually can be initialized on a VM as well.
Let's say example, a lot about let's say stateful applications from let's say SQL database, right? That runs on VMs. So, but we want to run the containerized versions of MySQL or SQL equivalent. Can I make use of this technology, layer 7 to somehow move my database over?
Yes. So Skupper actually support TCP protocol. So if let's say a database, usually you connect using a JDBC or any database connection, usually is TCP based. So Skupper will able to handle TCP connection as well. So just now you saw that when we create all those service A, B, C, right? That's just a normal Kubernetes service endpoint. But then when it route, the Skupper router actually will come into the picture, do a TCP/IP connection to another site.
Because I thought that this could be a quite interesting thing because moving without layer 7 router, right? The networking part is a bit tough, the traditional way.
Yes.
Very tough, especially even let's say we deploy the load balancer, right? It's very tough to talk about. It's mainly for network, not the application migration.
Mainly this one will free you from the existing problem that you need to expose a certain port number or just to configure the firewall for that particular TCP/IP connection to go through.
I was just curious for this, right? The other last question is, can you run using this, right, to do the Kubert migration?
I got expert there. I can talk later. Yeah, Kubert migration.
Kubert migration. Okay. I think on the left side also need to run.
We have
on
migration
cluster,
toolkit for virtualization.
on the virtual machine also need on Kubernetes cluster.
No need.
No need.
No need. So Skupper, if you think of it like Skupper is a router. So you can either install the router via the RPM install, or you can also initialize it using any Podman or Docker. So you can actually imagine that gateway box over there in the picture. You can imagine that as a Podman or Docker container running there.
Then we run a Skupper on the web.
So at this time, so this gateway is located inside the virtual machine for the network gateway. So which gateway? So
yeah, gateway is your router. So there's two sides. So Skupper need to be in both sides. So you need the qubit router to be on both sides.
so in the traditional infrastructure, for the upper layer we have the load balancer or firewall.
Yeah.
So yeah, at this time then we need to configure some configuration in the firewall or some load balancer first.
Yeah.
So to communicate with the Skupper.
Yeah, usually is okay because Skupper talk through the HTTP and UDBS, right? So if you're saying that you completely block the port 80 and 443, I think it's like there's no way you can connect out already. Yeah, so this is basically leverage on port 80 and 443. Again, like what Kiran showed just now, by using port 80 and 443, actually he is able to expose the port 8080.
So
yeah,
we can specify the specific UI route or something like that.
Yes.
So
So another similar use case, right? You have a Kubernetes cluster and you want to move it to OpenShift. And the same way we move the service one by one, we can actually do that by initializing Skupper router on both sides. So like you mentioned, you have your router on this Kubernetes cluster, and then you have a router on OpenShift cluster, and then you can have that connectivity between the two. Right, so if you have three different environments the same way, right? You have your traditional virtual machine, traditional applications running on VM, you have a Kubernetes cluster, you have an OpenShift cluster. To enable the communication between all these three, Skupper can also be very useful in this way. You have your routers on all the three different environments as well. And this was something similar to what I showed in the demo, right? I had three environments, my routers on all three environments, and I was able to communicate between the three different environments as well.
This one you mentioned about the HA on the back end, right? Is there the other way? There is
Front end.
two front end, multiple back end.
Yes, you can have that as well.
There is a couple of front end and back end resiliency. Let's say example, I got 3 sites, right? All these 3 sites have its own front end and back end using a layer 7 routers. Yes. So any site they want to hit, right? Maybe by default it's always the site 3, but maybe somehow the site 3 network disconnected. Yeah. People from 2 or 1 they can actually go to the particular site.
And there's a valid use case. I think that is what Skupper can do. I think the remember the dollar sign. So in step 3, I think you do an init, you create a token, then the step 3 is actually create the link. During create the link, the time Kiran actually give a name for the link. Actually, there's one more parameter you can set to the link is the cost. You can give a number like 5 for the cost. So let's say you want to you want the traffic to always go to the nearest one. So then the router will smart enough to add up the route, saying that, oh, this is 5 plus 2 plus 1 or something like that.
Like a OSPF like that.
Yeah, so it will be able to smartly route the best route for you. So like your use case is, it will always go for the nearest one. Then if that site is down, like just now it's scaled to 0, then it will go for the second available deployment.
Because the interesting part is that your endpoint doesn't need to point to the one that is running. Yeah,
It's the same name. That's the
that is the
beauty of it. You can have multiple backend binding to the same Skupper service.
Yeah, because now the challenge is that if we don't have this, right, if we don't have a global load balancer, so when one on the site down, right, the SOP is that people will use a separate link to go to another site.
Yes, that will be troublesome. Okay. But and then of course, provided your Skupper router also need to be out.
Usually the source namespace is at like one blue box is one lane, like one local network, or is it like one node?
The namespace?
Yeah. Usually how big is the namespace?
It depends. So if I understand your question correctly, it's like how big you want your namespace to be, right?
Yeah. Is it like one service, one namespace?
It depends. It
You can have
depends.
multiple as well.
Yeah, it can have multiple as well. So it's a terminology in Kubernetes that people like to use a lot, like how much resources I want to give a team. If I give you a very huge namespace, you can have all the CPU power on that cluster. Or I just want to slice one small namespace for you, then that's all you have.
So usually the consideration is about resource management, not about routing granularity.
But it is about granularity as well. As you can see here, this diagram, you can actually have separate router on different namespaces. And you can actually form a different link. So you can imagine that the router itself is quite flexible. Maybe this diagram belongs to team A. They form a cluster of network, a WAN network between the namespace 111 on 3 different clusters. But maybe another team, they can form their own WAN for their own application without affecting this setup. It's quite flexible, I can say.
Though the like price of each route can only, we can only set the price if it's between namespace. Like within namespace, can we?
In the link,
Yeah,
during the link creation, you need to set.
so the link is only cross namespaces, or we also have links.
You can
Within
cross
namespace.
region, you can cross namespace. So like what Kiran showed just now is actually crossing the region. The link is actually formed from APAC, which is this region, to US. So it's a two different region the link is forming. So you can imagine that Kiran also can create two namespace within the same cluster, and you want to form the link as well. That can be doable, but no point, right?
It's the same cluster already,
Yeah.
so you don't need.
Oh, but you can decide the price.
Yeah, you can
within
decide the price. And the price is just a number. You just give a number, then it,
Oh, but it means that you can decide the routing preference.
yes, that's exactly what you do. You can
Still
control.
doable if it's
Yeah, in
within
control.
the same cluster, same namespace.
Yeah, usually same cluster, you want to give a very low number. And then like if you want to go to a very far away cluster, then you like I think all of us we know that how AWS charge us when we go out from AWS cross region. And there's costs that involve whenever the traffic go out. So in this case, like let's say you don't want to hit that cost, you always want to save your cost by hitting the closest within the same AZ kind of deployment, then you can actually do that. Is that answering your question? Okay, thanks for the question.
At this time, we will have another, so maybe public cloud or private cloud, so maybe the public cloud 3. At this time, they currently, so our private cloud is connected to the public cloud 1 and public cloud 2. But so we didn't connect to the public cloud 3, but so public cloud 1 connect to the public cloud 3. At this time, we can communicate from public cloud 1 router to public cloud 3 router.
Yes,
Indirect connection.
indirect connection. It will reach there.
We don't need to configure account to communicate the public cloud to
Don't need.
the public cloud to
Yeah,
oh,
it will reach. It can
Oh.
reach.
yes. Thank you.
Yeah, so this one last slide was, I think I already touched on this slide. So high availability of services. When you have different services running on two different environments, this private cloud can actually reach out to that multiple environments as well. Right, so that's pretty much the use cases I have for today. And I think that comes to the end of the session, but Q&A.
Question regarding the service discovery. So usually when you are running services in only one cluster, you usually use internal service discovery, right? So you have a specific FQDN for internal service discovery. So when you discover services across the clusters, the service discovery FQDN remains the same.
Yes.
It's the same like dot namespace dot svc dot.
Oh no.
Right.
So it depends where you create the Skupper service. Maybe you go back to your environment and show that the one that not shows. Oh, you got it.
I think the first step on the namespace of namespace.
Is it?
You can show there's one step on the namespace.
Yeah. So when you create the Skupper service, that's where the Kiran actually exposed, right? The service actually sit in the namespace where the Skupper router sit also. Imagine like you have one namespace that you can Skupper in it, then the Skupper pod actually sit inside that namespace. So you can see here the service that expose the thing is here. The FQDN will always follow this service name dot this namespace. Yeah, but then if let's say you are looking at other, then you will not.
So this, I want to reach from this particular service to other service in the other cluster.
Yeah.
So I'll still give the namespace.
Yeah, so you just get this service to other guy. Yeah. So it will be the standard Kubernetes service format. So the service name followed by the namespace, then cluster local, SVC cluster local. Yeah. Or you just skip the SVC cluster local as well. That's a very good question.
Yeah,
Yeah.
because we tried such similar things, but we failed. So
Yeah.
and another question is regarding the scaling.
Yeah.
So let's say I want to scale my backend in only one cluster. Let's say this is one cluster, and I want to scale my backend to, let's say, multiple pods. So in that case, would the router be a bottleneck?
Yes. No. Yes. Router will always be the bottleneck, but you can also scale the router.
You can scale the
You
router
can
as
scale
well.
the router. Yeah. You can also scale the router. So yeah, that's a very good point. You can scale the router, or you can separate the router for different namespaces need. That's also one of the way you want to do it. So the way how it works is that the traffic routing, it will follow the standard Kubernetes way, the label and selector mechanism. So kind of like if you scale, it will follow.
How about the performance? How about the network performance?
Yeah, so the network
like the
performance
mix,
is a good question. The reason why there's Cupid router involved is actually Cupid is a high performance router written in C programming language. So you can imagine that Cupid is able to handle very high workload. But the concern here is always the resources and the latency that you are trying to achieve. And also the TCP IP connection that you establish actually costs memory as well. So you will need to consider that at one time how many active connection you are trying to create, and you need to allocate same amount of resources to the router.
So that this traffic is so through the internet. So that so we need the more internet connection.
Yes.
So to communicate each other.
If you're going
It
through
can
internet,
be
yes.
it can be impact so in our communication. So like during the between these two clusters, like this AWS US and AWS like this of private cloud. So yeah, at this time they have the so many hosts. So at this time we can get the delay. So to connect each other.
Yes, I think I don't really
So
quite catch you.
can we get so a lot of delay time? So when we communicate each other, so through the internet.
Yes, it will be quite delay if you're talking about going through the undersea cable to other side. Yes.
Yes.
Yeah, the
Because
delay
right-
is unavoidable.
Yeah. Right now, some service are located in Singapore, like the some services are located in US. At this time, when we communicate each other at this time, so
that is unavoidable. Unfortunately, yes. The latency actually is something that depends on how fast the connectivity between the two routers. So if you are talking about just data center 1 and data center 2 within the Singapore, I think is okay.
Yeah.
But if you're talking like just now, the demo is actually flying all the way to US from Asia Pacific, then you can actually feel the latency over the undersea cable.
Yeah. Thank you.
Thank you. Yeah.
I see some famous service mesh. They also offer same function.
Yes.
So
Yes.
like Slium also offer same, maybe more popular than one.
So I think
So what different
the
Skupper
comparison
company?
is yeah. So chances of people will ask question like this. I can do the same with service mesh. Yeah. I can do the same with maybe Submarina. If you've heard of Submarina, it's one of our offering. So what's the difference, right? When do I use it, right? I think at this picture you can clearly see that service mesh at this point of time is still using a sidecar pattern. So sidecar pattern meaning that each of the pod you will have a sidecar container, two container in one pod. And Skupper doesn't do that. Okay. And also for you to establish the mesh, you actually need forming a mesh crossing two cluster, you actually need something called mesh federation, meaning that the gateway from one cluster need to communicate with another gateway, then only forming the mesh clustering. So that's a very I can say complicated scenario where Skupper is just creating a link, and it's much more easier and much more control, and it doesn't really require a cluster admin to involve in this case, because just now you saw, right, it's just basically spinning up a deployment with a router inside, and then it's just labeling the service just to do the routing and exposing it through the Skupper network. So the different use cases, there's different use cases, but then service mesh come with a few good features that Skupper cannot do. Say, for example, if you are trying to do a very fine-grained A/B deployment, you want like 10% traffic to this, 90% to another site, then it's not for Skupper. So it depends what use case you're looking at. I think different use cases. That's a very good one. I think quite a lot of comparison you can get from these three products, because they also do the similar thing. Yep.
Okay, that's all. I think.
Yeah, that's all I think.
About it.
Thank you guys for coming.
Yeah.
Thank you very much.
Yeah. When you link from cluster I to B and link from B to I, have anything different or the same?
Okay, so the caveat here is that you need to be accessible. Like just now when Kiran demo, the third cluster that Kiran running, in case you didn't notice, is actually a mini cube running inside his laptop, which there's no way for you to reach from the internet. So in that case, the mini cube is not, it cannot be the one that issuing the token. The one that issuing the token must be reachable from either of the cluster. So he choose the one in the APAC region where it's an internet accessible website a cluster, then only you join the cluster from his laptop to that cluster.
But two public cluster.
Yeah, you can do both
So
sides.
from I to B
Yeah.
or from B to I,
Yeah.
the state automation.
It's the same. And you can do HA as well. You can create multiple links.
So if I have
Thank you. Yeah. I say let's do a OC get SEC.
I need to install again. No, it's just one comment.
The CLI. So you see there is a backend cluster service here, but actually the pod is not running here. It's just a Skupper service.
So
Then you just get services a lower backend.
Where do you get which folder?
So you can see that it is a normal Kubernetes services, but then where does it point to, right? Then you can go to the selector section and you can see that, go down to the selector. So if the selector actually choose these two labels, where it actually pointing to the router, then the router will decide where to go.
this service was automatically created by Skupper.
And just now it just created.
When it pause.
Yeah, when you Skupper init and Skupper expose, the Skupper expose will create this service for you.
Yeah, perfect.
One more thing is, as I see that all the services are cluster IP, all are local, and other cluster also must be having all the services as cluster IP. How does communication actually happens. I might have some other CNI, everything else running on some other place.
Yeah.
And
It's a
the traffic
layer,
actually
it's
might go
a
out of
layer
focus.
7. I think it's okay for your CNI to be different
Yeah.
in this case, because the traffic you can imagine, like I initialize a curl to the service. The service, by using this selector, it go to the Skupper port. And then from the Skupper port itself, it know that you are actually accessing this service. From there, the Skupper port will communicate with the whole WAN, the WAN network, and then it will know where to go to.
So Skupper will use so DNS mesh services to resolve local DNS name.
There's no DEN. Yeah, you will use the Kubernetes DNS services.
Okay.
Yeah, you use the Kubernetes DNS.
So Skupper will automatically declare the DNS record. So based on the Kubernetes configuration. So we will need to declare this local DNS record. So maybe that like this so for the first one, so like this the hello maybe could be just something like this, and then default.svc or something like that. At this time, how will so Skupper resolve this local DNS name? So from one cluster to another.
It is a default Kubernetes.
It's a default
The,
Kubernetes
yeah.
service.
Skupper don't have some DNS
Yeah,
related to
Skupper
that.
never do anything special.
Just request to the router bot. Router bot have the know the zip name to redirect to the
Yep.
Also we so to communicate each other, so we need to use the route path rather than the normal cluster. So FUDM
layer 7.
layer 7.
Layer 7.
This is a Kubernetes service. If you scroll up a bit, you can see that the service that Kiran showing is normal service. You see
Normal
the stop at the API version. Go down. Yeah. So yeah, API version 1 kind service. It's a normal Kubernetes service. There's nothing special about the service that's Skupper create. Only the selector and label, and also the annotation. So you can see that there's annotation there. Remember, Kiran actually showed that there's 2 upstream projects that we combine together in order to achieve this. The controller and also the stupid router. Yeah, the router is the port that we're pointing to just now. And then to configure the router is actually the job of the controller, which is Skupper in this case. Skupper actually read the configuration, and then when you form the virtual application network, they will share the information within the network. And it will just, whatever you configure, all the router will get the same configuration. And they know that now that there's this backend service hosting in this cluster, and whenever people trying to reach this endpoint, it will know that you need to go here and go to the actual port that's running on that namespace.
So I would like to know one question. That is, so when we communicate from one container to another. So at this time, they normally, so when we communicate locally, so we just only use the cluster, so FUDNA. So rather than the normal route path. So at this time, can we use the service name rather than the route URL?
This is service name. The one that Kiran called is actually the service name. Yep. Service name.
Backend service.
Yeah.
So, okay.
There's no ingress involved in this point. It's just curling the service within the same namespace.
So at this time, so like the Kubernetes cluster, so well know, so to the another locate service name.
This service exists in all 3 clusters actually. When the moment you expose a Skupper service, all 3 clusters that form the virtual application network will have the same service created. Yeah.
Also can be conflict that if we declare the same service name, so between these two clusters. So when we communicate each other, so we set the same service name. At this time, it can be conflict or not.
It
You
will
mean
not.
you
It
have
will
a
not.
local service name?
Yeah.
Oh
yeah, if you have a
Yeah,
local
yeah.
service name,
It
same
will
Yeah,
name,
fall
yeah, yes.
for
yeah, you cannot. I mean,
conflict name, right?
yeah, there's a conflict in Kubernetes, right? You can't even create a normal Kubernetes service with the same name, in the same namespace.
Because it's in the default Kubernetes service.
Yeah, it's a normal Kubernetes service.
Yeah. At this time, I mean cluster A. So I also use the like this. So like the depth one. So like we declare the service name like the depth one. So in the so Kubernetes cluster B. So I also declare the like depth one. So for the service name. At this time, can we communicate each other or can be conflict when we declare the same service name? For
To Skupper actually it's the same. Maybe you just show them you try to get the same service name at three different clusters.
Yes.
Yeah. To Skupper it's actually the same. You just OC get SBS.
Can work around with manual edit the service after
Yes.
import
Yeah.
and we select bot manually on the current service.
Yeah, the OC get services. Yeah. Okay. Yeah. This one is better. So you can see here is actually this is the global so-called global service name that you created, a logo backend.
Yes.
All three cluster will have this. All three cluster will have this. All three cluster will have this. So you can actually all three cluster will have the same exit the shells. This is sort of like the global one, but then you can see here and here is different because this one is a fake one. It's backed by the router, and this one is actually pointing to the real port. So the one above also pointing to the real port. So the all three will see the same name. All three can call this same name within the namespace, but then when it actually respond, I think the one that leaving this will be responding to you. I mean, if you turn off the one obviously will not respond to.
Currently, all three of them are connected over internet, right? All three of them are connected over internet, right?
Yeah, now it's connected
So,
over internet.
Which one actually has the public IP? Is
The
that
middle
router?
one now. Now it's the middle one.
Only one needs to have that
Yes.
public IP. That's it. And the middle one is having that because we deployed controller and router both there. Is it?
So if you want to understand that, actually you can open up the token file. Can you beam the token file again?
They're called AWS.
Yeah.
AWS. Yeah.
Something like that. I don't know why you just need to else. So the middle one is the cluster that issue the token.
It got deleted.
Oh, it got deleted.
It's okay. I got it.
Yeah. So the token contain the endpoint that you can join the cluster, join the web. So it need to be reachable for the connection.
Wherever you create a token,
It need to be reachable. It need to be reachable. It can be over the internet or it can be cross to data center, but in a private network. But it needs to be reachable.
What about the charges? Are they separate if you connect Singapore, Australasia, USA, and Europe?
Yeah.
Are the charges separate or how do they come about? The highest, they use the highest though.
Yeah, that's the cloud provider charge you, not us. Yeah, we are just a router running inside the AWS. So the cost will be usually the egress cost will be from AWS.
The digress with
Yeah, the traffic, how many bytes you send over to another site of US or where. Yeah, they count by bytes, so I think it's very expensive.
Can you give an idea what can happen if one of the routers goes down? Like how
Yeah, if
can
you
things be
kill
done?
the router, I think Kubernetes will revive it for you, self-healing. But if let's say you really like scale it to 0, then it will try to find another route. So you go back to the slide, then you have another route. So Skupper is smart enough. So if let's say we are if let's say we are looking at this, right? If this is the router that you actually having, right? You are forming a link from here to there, then maybe one of the link is broken. Then it will actually find its own way to go to the place that you want to go. As long as there's a route there, then you can actually reach where your service.
Oh, I mean, if the router is down, will
Yeah.
the other routers realize that the router is down?
Yeah, they will,
Like,
because they are
real time.
constantly exchanging information.
oh, so it's constantly changing instead of like only routing when request comes.
Yeah, it's constantly exchanging information. Like just now when we scale one of the port to 0 at one cluster, actually all the router know.
Oh, I thought the scaling was scaling the service. It was
Yeah,
scaling
you're
router.
scaling a service, but then you can scale the router as well. So the router will not reachable. By the time when you issue the Skupper service status or Skupper link status, it will say the link is down. Yeah, question? No. It's a good discussion here. Think interesting, very interesting.
It's always more interesting with smaller crowd.
Yeah, I know. I mean, we can open discussion here.
45. I think today there are about four occasions. One is across the road, AWS.
Yeah, today is quite a busy day. Yeah.
Didn't go so many places.
Yeah. Thank you for
So
coming
many
here.
pizzas.
Yeah, thank you for coming here. I mean, happy to have you here. Yeah, I think that's all. So if you guys just want to hang out, we're still here. So I think that's the end for this session. Thank you.
Thank you.
So do it because I did the session before.
Oh, that's all.
Good night.
Hey, thanks. See you.
Bye. Recording audio.